They have found 7 Earth-sized planets,
identified as many as 50 new planets, the discovery of 500 new planets.
Now stands at well over 3,000.
Yes, it is very exciting to go out and look for exoplanets. To even have a string of hope that there may be life outside our solar system, because at the end of the day, it's human nature to explore, to look for worlds outside our own. And this is why, for years, we have been continuously searching for exoplanets. And it's even showed up in the movies and shows we watch. It's like Star Trek, Star Wars, and various more. This idea of exoplanets or planets outside our solar system have been mentioned various times. But let's rewind a little. Scientifically, what really are exoplanets? So, as for the definition, exoplanets are basically planets that are beyond our solar system. Generally, they orbit another star like the Earth orbits the Sun, but there are also free-floating wanderers, which are called rogue planets. They do not orbit any star. Sadly, they were ejected from their planetary system in which they were formed and then drift alone through interstellar space, unattached to any star. Even though this idea of exoplanets had been mentioned in various fiction, movies, and series, the first exoplanet was not actually discovered until the 1990s. And the exoplanet was found was a hot Jupiter. That's nothing like what we see in our own solar system. And it's not only hot Jupiters. There are super Earths, mini Neptunes, planetary systems that are smaller than Mercury's orbit. The possibilities of worlds are endless and our journey is just starting. There is so much more to find, and in this video, in our voyage today, we will be exploring exoplanets. We discussed the crazy type of exoplanets that can be found, but how are they actually classified into those types? It's done through their size, which is their diameter, and their mass, their weight. Through these two measurements, we can see composition that range from very rocky, like the Earth, to very gassy type planets like Jupiter. So far, we have categorized exoplanets in these following types: gas giant, Neptunian, super Earth, and terrestrial. Let's go through each one of them. Gas giants are the size of gas planets like Jupiter or Saturn, but they can even be much larger. And they don't have to necessarily be cold like them. They can also include hot Jupiters. Neptunian is similar to size to Neptune or Uranus in our solar system, which have hydrogen or helium dominated atmosphere. Mini Neptunes, for example, are smaller than Neptune but larger than Earth. They're in that middle zone. Terrestrial, as the name suggests, are Earth-size or can even be smaller, which are mostly made of rock and metal. Some could possess ocean or atmosphere and perhaps even other signs of habitability. Super Earths are a super version of Earth. They are typically terrestrial or rocky, are even more massive than Earth, but they're lighter than Neptune. And some of them may or may not have atmosphere. What's even more intriguing is that scientists have found some sort of strange gap in these classification types. And it's been called the radius valley or the Fulton gap. So these are basically those planets between 1.5 and 2 times the diameter of Earth. The given reason for this could possibly be that the planets that reach this size clearly attract thick atmospheres of hydrogen and helium thick gases and balloon up into gaseous planets. While planets that are smaller than this limit are not large enough to hold on to such atmosphere and remain primarily terrestrial bodies. It's still a mystery though, and scientists are still exploring various causes of this gap. Now, the main question remains is, how are these worlds that are so far away from us, the nearest one being 4 light years away, which is 24 trillion miles? It's not common to see it through your own telescope, like the way you might expect to see Saturn through your telescope from Earth. It's not as easy as that, because they're very far away and so tiny that it's almost impossible to detect them through direct imaging. Compare it to a situation where you want to find a mosquito flying around those giant spotlights on the street. Well, if you're standing very close to it, you might be able to spot it, but direct imaging is like you're in an airplane and you want to spot that mosquito. You can see the light, but there's no way to be able to spot that tiny little insect. Instead of making direct images, astronomers have used various indirect measurements and observations to detect exoplanets, and those methods have worked. And it's because of those indirect techniques that the total number of exoplanets found till now is 5,235 to be exact. Yes, we have come a long way since the 1990s. The two main techniques are the transit and the radial velocity method, transit method. are measuring the dimming of a star, which happens when a planet passes in front of the star. Now, this is similar to what we explored in the previous video, which was used in the DART mission. The next one is where you monitor the spectrum of a star. The spectrum of a star is basically the light from the star, which is split. Like, for example, you pass a light through a prism, and that's split into different spectrums, different wavelength of that light. This allows us to see if there's any planet, mostly planets that are very close to the star and huge like Jupiter, which are pulling on its star, causing it to wobble, which can be detected using Doppler shift. The Doppler effect is essential in this method because it allows astronomers to measure the radial velocity of a star, which is the speed of the star away or towards us relative to us for observing. Now, the reason for this wobble is because gravity is a mutual attraction. The planet has an effect on the star and star has an effect on the planet. The star and the planet both exert a force on the other, and through this we can find a stable point, which is the center of mass between them about which both the objects orbit. So as the planet tugs on the star, which causes it to move towards the observer and go away from the observer, there is changes in the spectrum of the light of the star, and that can confirm the presence of a planet around that star. Now, this can help us determine the mass and orbital period of the planet around the star, because the more massive the planet is, the larger the wobble or the radial velocity will be measured. The next method is called the transit method. I'm sure you would have heard the Venus transit, which is when Venus is aligned with the sun and it causes it to transit. It's a very rare event, but as it passes through the sun, you can see spots on the sun because Venus will end up blocking parts of the light from the sun, which causes that shadow or the dimming of light to appear. This similar technique is used in the transit method to find exoplanets. So as an exoplanet passes directly in front of the star, it causes the light of the star to dim by a measurable amount. The amount that the light dims can help us determine the diameter of that planet. So if the slight dips in brightness repeat at regular intervals, it can help us to calculate the orbital period of the planet. But the drawback between both these methods is that both of them favor discovery of large planets and short period orbits because they're much easier to detect. Most of the planets found so far are more massive than or larger in size than Earth. So it does not mean that Earth-like planets do not exist. It may just be that the shortage of small rocky planets is an observation bias because smaller planets are just more difficult to detect using the methods we use currently. This study of exoplanetary systems provides us with a new perspective, which teaches us that there is so much more variety among planetary systems than we had ever imagined a few decades ago. Our galaxy contains at least 100 billion stars, our sun being among them. And if each of these planets has not just one planet, but like ours, a whole system of them, then the number of planets in the galaxy is truly astronomical. We're already heading into the trillions. There's a huge probability of finding habitable planets, and we don't have one galaxy, we have billions of them. There's so much more to explore, and this was just a sneak peek into the research that has been done. I hope you enjoyed this voyage of ours.